So I just wanted to wrap up the cop chases speeder problem, and I wanted to give you an idea on an approach that might be a little bit easier. So after the 7 seconds, let's start the time then. So this is after 7 seconds. So this is cop moves constant velocity, right? Well, it makes the position time graph pretty simple. So this is position, right? And this is time, second meter. Okay? And I'm going to remind you of where each person is at. Okay? From where the cop started, the cop's at about 86 meters, right? So there's the cop. Okay? And then the car is like 180 meters. Because the car went 75 meters before the cop started. Then the car went 105 meters while the cop was speeding up. And the cop only went 86 meters while he was speeding up. Well, at this point, there's our cop. He's going about 25 meters per second. And here's the car the cop's chasing, which I should draw my arrow a little bit smaller. So I'll do that. The arrow should be about, maybe a little more than half the length of the cop's velocity arrow. And, well, it's now a really simple problem. We got 86 here. There's the cop. The slope should be steeper. And there's the speeder, or the car, at 180 meters. And his slope's not as steep. And we want to find that time t and maybe that position there. The equation for this line, for the position, this is from the first lab we did all year, is going to be 86 plus 86 meters plus, I have to intercept, plus the slope of the cop's graph. I'm going to call it 25 meters per second, right, times t, right, and that's going to be the position cop. That's an equation for the position of the cop. This line, so that's just y equals mx plus b, right? You might be more comfortable if I write it sort of the other way. So I can write it this way: x cop equals 25t plus 86, right? That's without units, so you can see the y equals mx plus b. So that's the position of the cop based on the position time graph. And over here, I'll put the position of the car that the cop's chasing, right? So position of car is going to equal, let's see here, 15 meters per second. That's the velocity of the car times t plus 86, right? And I can simplify that and just write x car equals 15t plus 86. So you can see this is pretty simple, right? I can just set their positions equal to each other. I'll let you do that on your own. I can say 15t plus 86 has to equal 25. I messed up. Sorry. This is not 86. That's 180. meters. So that's 180 meters. So that makes 15t plus 180 equals 25t plus 86. All right, and you can see if you solve this system of equations, you're going to get, let's see, 10t is equal to 94. And this is what we got before. Divide by 10, you're going to get t equals 9.4 seconds, right? Now, this is 9.4 seconds after the 7 seconds of the cop car speeding up, right? So, and then this is also 5 seconds after the car originally passed the cop car. So, let's say you want to know how much time has passed since the car first passed the cop car. That would be 9.4 plus 7 plus 5. So, that's a total of about, I think it's about 21.4 seconds. And this is 21.4 seconds after car passes cop. Now, on this graph, you can take your 9.4 seconds we just found, and you can actually figure out where they're at. It doesn't matter which equation you use. I'll just do it both ways so you can see. So you can take either equation, take our 9.4 seconds. So they should be at the same position. And this will just be a final way to check our work. X for the car, that's position of the car, again, is 15t plus 180 meters, right? So position of the car is going to be 15 times 9.4, and that time is after the cop car is sped up, and after the car originally, the 5 seconds the car passed the cop. Okay? So, what do I get here? Let's see. Talking about 15 times 9.4 equals plus 180, and I get 321. So, it looks like 321 meters is the position from where the cop started that the cop actually catches this car. Now let's just check with the cop's position equation. Position of the cop is going to be 25t, right, plus our original 86. And so the position of the cop is going to be 25 times 9.4 plus 86. Let's see what we get. 25 times 9.4 equals plus 86. And sure enough, we get the same thing. So I'm pretty confident now that I got this. Anyway, hope that helps. That's your wrap-up for the cop chasing car problem.